Okay, now at lower temperatures, the electrons of the donor which are not involved in covalent bond, that is the free electron, the fifth electron in the phosphorus atom, it requires the small energy difference and it jumps to the conduction band. This is at very low temperatures, because low meaning it will still be higher than 0 Kelvin but not too high, because these free electrons, they have very small binding energy. So you apply very small amount of heat itself, they break free from the binding forces and they enter the conduction band. So at low temperature, the number of charge carriers is equal to the number of electrons in the conduction band, which is the number of ionized impurity atoms. What does this mean? The number of electrons in the conduction band, of course, it is equal to the number of ionized impurity atoms. Ionized meaning an atom which gains a positive charge because of the loss of one electron. So if one electron from the phosphorus atom is going into the conduction band, there is one ionized phosphorus atom. So the number of electrons in the conduction band will be equal to the number of ionized impurity atoms. And those are the particles responsible for conduction at low temperatures. Although the semiconductor is made of silicon, at low temperature it is only the phosphorus or whatever donor you are using which contributes to the conduction. As temperature becomes higher and becomes enough for the electron in the valence band to acquire enough energy to become free, thermally generated electron hole pairs are created. So what does this paragraph say is, as you keep applying energy, first of all those free electrons from the donors will move to the conduction band. Once all the free electrons from the donors have moved to the conduction band, if you continue to apply more energy, the silicon atoms, the electrons of the silicon atoms, they break free and they start moving to the conduction band, just like a normal semiconductor, like an intrinsic semiconductor. So at this level you start getting electron hole pairs. So when the phosphorus electrons gained energy and moved to the conduction band, there was an electron and an ionized atom or an atom with a positive charge. Once all the donor atoms have been ionized and all the extra electrons have moved there, if we continue to apply energy, then the silicon atoms, they start losing electrons. The electrons go to the conduction band and the valence band remains with holes. So in that situation we get electron hole pairs. So now the number of particles, number of carriers will be the number of electrons in the conduction band from the donors, that is the phosphorus electrons which are now in the conduction band, plus electrons in the conduction band from silicon, plus holes in the valence band. That is equal to number of ionized impurity atoms plus thermally contributed electrons, which is what we saw here, plus holes, Ni plus Nd. This is electrons, Ni plus Nd plus Ni, where this is silicon electrons, this is silicon holes, and Nd refers to the number of electrons from the donor.